Hello everyone, welcome back to another video, and in this tutorial we are going to study about how to log transform a negatively skewed variable, right? In my previous video I told about how to transform positively skewed, but if a variable is negatively skewed, right, then how can you do that? For example, first let's go to this data here in the variable view, and we have got a data here, and here is a one variable which is negatively skewed. So first we go to this Explorer, and first we go to Analyze, Descriptives, and here Descriptives. So in descriptives, I already have this variable which is negatively skewed over here, right? So fixed broadband connections, this is the variable. So I've already put it here. So you have to go to the options and click this skewness and kutotes option over here, and then continue and OK. So here you can see in this skewness it is minus 0.397. so this minus shows that our variable is negatively skewed, and rest everything is n is the number of variables, and all minimum, our minimum is 13 and maximum is 45, right? So you have to you should whenever you take a log, there should be no values in negative. Like the minimum value is 13, it should not be in minus. So if it's in minus, then first you have to bring it into the positive by adding the required numbers, right? So first now we can check this from another Analyze, Descriptive, in Explorer. In Explorer also we can go to the statistics, input this outliers, and in the plots in histogram also we can check that whether it's negatively skewed or no. So we check the same variable, fixed broadband, OK, and you can see now here in the first test, it's a 0.06 and significance is 0.012. so it's not normally distributed. For normal distribution, the significance should be greater than 0.05, and here also Sperrville also it's significant. If it's significant, it means that it's not normally distributed. And here also you can see this portion, the majority of the data is towards the right side, and towards left side there is nothing, right? There is a lot of space here, so that means this data is negatively skewed. This is negative and this is positive, so this is a negatively skewed. And along this QQ plot we can see almost it's here, right? So along this line, and in this box plot we can see that there is no outliers here, right? If there are outliers, then the lower and upper this boundary below and above, there will be some values. So now how to do it? First we have to go to transform, we have to go to the compute variable, and in compute variable here you have to write the name. So I say F fixed broadband, FBL, I call it fixed broadband. And what I have to do here is go to arithmetics and log 10, right? And within this parenthesis you have to subtract the maximum value plus 1. So 1 plus the maximum value is we saw here was 45, right? So here the maximum value was 45. Yes, here the highest value is 45. So 1 plus 45, 1 plus 45, and subtract it with the variable. So the variable over here is fixed broadband, right, FBB, and fixed broadband, I gave this name. Now click OK. So now we have got another variable here at the data view at the end. So log of FBB. Now this is our variable which we have log transformed, and it was negatively skewed. Now let's see whether this log transformation has worked or no, because sometimes if your data is almost okay, then the log transformation even doesn't work, right? So we put this as well, we put both of these here. Our options are the same which were previously. So now let's see our results. Yeah, so we have two variables in case processing summary. First is the fixed broadband, the normal one, and the second is LFBB. In both of them 242 cases and 14 are missing, which I have deleted to bring them normalized. In total were 256, right? So in the first one the maximum was 45 and now 1.52, and the lowest is 0.08, and here the lowest was 13. In the test of normality you can see, so our the normality has even gone bad, you know. Previously it was better. This statistics should be closer to 0. Previously it was 0.06 and now it has been 0.13. So this has increased and significance has gone close to 0. Previously it was a little higher than 0, like 0.012, but now it has gone here. So this thing shows that sometimes if you log transform, the result is not going to be better than the previous one, right? So like our variable was already close to 0, like 0.06, so we did not need it to log transform it, although it was negatively skewed a little, but it was not that much negatively skewed that we need to log transform it. So after doing the log transformation, we have come to this conclusion that the previous without log transformation, the result was better, right? So this is the result without log transformation, and if you want to see the curve, you can double click here and go to the elements and distribution curve, right? So this almost it's here, and although it's slightly negatively skewed towards this right side, but still it's okay. And when we log transform, it's even gone, you know, worse. So we can see there's some little data outside this curve, but you know it happens because perfectly, you know, within 100% within this, it's usually not possible. So now this was the curve. Ideally your data should be all along this line, but you can see at the negative end there is some above, and then here it is some little above. So because of this, we have seen in our data it's not normally distributed, and there are no outliers. And this is the data which we have made it log transformed, right? Viewers, in this video we discussed about how to do log transformation of negatively skewed variable. So sometimes it's not even necessary to do that. If it's a lot more negatively skewed, then you can do it, but if it's a little negatively skewed, then it's okay without even doing log transformation. Thank you very much. If you like this video, please hit the like button. Bye.